All right. Before we get started, a few housekeeping items. Only panelists are displayed and heard, but we do want to hear from you. Please put in any questions you have for Dennis into the Q&A panel in your Zoom panel using that Q&A button, not the chat, or else we won't see it. And Dennis will be answering questions towards the end of our presentation. We will be sharing a recording link of this presentation as well as the slide deck after the session. And we'll also share Dennis's contact info with you all after the session as well. A little bit about the host of your webinar today. My name is Raquel Cloyd. I'm the Business Development Manager here at Intellect. In case you aren't familiar with us, we are a no-code compliance, quality management, and environmental health and safety software solution. We work with companies across various industries to automate their quality and EHS processes, helping them save time preparing for audits, maintaining compliance, and doing so in a user-friendly and efficient manner. And I want to welcome back Dennis. Dennis came a few months ago and spoke on a very important topic, the cost of quality, and he is back today to share his insights on FMEA. Dennis is the principal of Devos Associates. He's a fellow for the American Society for Quality ASQ and an ASQ Quality Division Chair. He is a recognized authority on a variety of quality-related subjects, including FMEA, root cause analysis, cost of quality, auditing, lean methods. He was formerly an engineer at GM, has a lot of automotive industry experience, provides training and advisory services for manufacturers, has 25 years of experience with FMEA, including the new automotive AIAG VDA approach. All right, Dennis, I'll hand it over to you.
Okay, thank you, Raquel. Thank you, Ann. It's a great pleasure to be back. I hope everyone can hear me. It's a great pleasure to be back here to do another webinar for Intellect, and I want to talk to you about my very favorite topic. It's FMEA. So the objectives are really just to cover the fundamentals. We will talk about design FMEA, and we'll talk about manufacturing process FMEA. I'm going to reinforce to you how important it is that our risk assessments are tied to function, and that's very, very important. We'll be covering the 3 dimensions of risk, which are, oops, I apologize. 3 dimensions of risk. Severity, how bad would it be if a failure mode happened, and what would the effect of that be on a customer? What's the probability of occurrence and the cause of a failure mode? And then finally, if the failure mode happens, what's our ability to catch it? Or would that defect find its way to the customer? We're going to walk through the format and then be talking about some tools for identification and mitigation. So many of the examples that I'll use will likely be from the automotive industry, but it's so important to recognize that this FMEA tool can be applied across any type of sector, not only just manufacturing. In fact, we can look at failure modes associated with service delivery too. And I'm just thrilled to know that there are people here on the call today from a variety of industries: the automotive industry, aerospace and defense, oil and gas, medical device, pharmaceuticals, and I welcome all of you. And I will be talking at a level that will be universally applicable to everyone here. So we hope that you enjoy the presentation. Raquel, why don't you get us started with a poll?
Yeah, we're curious to know where everyone is at in their FMEA process. There is a poll that is being launched. We invite you to please vote in the poll. What is your primary interest in joining us today? Are you more interested in design FMEA, process FMEA, both? Or you're not sure, you're just here to learn and figure that out later. We will give everyone another minute or so to answer the poll question, and then we're going to share the results in a moment. All right, I think we got a few more people that are answering the poll question. All right, we've locked it down. The results are, I've got about not quite an even split between process FMEA and both. So it seems like if you're interested in process FMEA, you're also interested in design FMEA, but not only design. And about 22% are I'm not sure yet. They're here to learn. So that's really great to know where everybody's at. Thank you.
That's perfect. Thank you, Raquel. That will help me inform, maybe some of the examples that I use or the way that I approach this. Now, of course, I can't teach you FMEA in 1 hour, right? I can't make you expert practitioners in 1 hour. In fact, my process FMEA and my design FMEA classes are 2 days each. But I do want to whet your appetite. I do want to make you excited. The title of this presentation is Achieving Near-Zero Defects with FMEA. And how would you do that? You can't really prevent defects unless you can see into the future, right? So FMEA is actually a crystal ball that we can use to see into the future and anticipate risks, anticipate failures, anticipate design deficiencies, manufacturing defects, and head those off before they even happen. FMEA is just a huge, powerful tool. And my goal today is to make FMEA your favorite 4-letter word that starts with F. Like I started to say, the FMEA is predictive. And the challenge is to sit with a new product design, perhaps, or sit with a new manufacturing process. Maybe it's a new assembly line. And before you even build the thing, before your designs are even finished, you think ahead to, in a product design FMEA, for example, I've designed a product or I've designed a feature, and how can this thing I've designed fail to meet design intent? And that's really the purpose of FMEA. Looking ahead, I know what this product has to do in the marketplace. I know how my customers are going to use it. How suitable is my design? Is it going to really be the right thing for my customers, or am I going to be living with perpetual warranty and other problems? Manufacturing process FMEA, similarly, now addresses risks associated with manufacturing. Right? So how can a step that I have in a manufacturing process fail, and that failure in my manufacturing process somehow results in defective product that gets to my customer? So we're going to talk about both of them at a fairly high level and introduce you to both of those. So why do we do FMEA? Well, the idea, like I said, is that FMEA is predictive. We're predicting what may happen in the future. So we're identifying potential product failure modes and manufacturing process related failure modes. They're potential. They may not happen, but we're thinking ahead towards what can happen, how bad would it be, how likely is it, and then what level of control do I need to prevent this design deficiency or prevent some manufacturing defect. Once we understand the failure modes and anything that can go wrong, we frame that in terms of the effect that failure mode would have on our customers. And then, right, again, thinking about which design elements could require additional prototype testing, which process variables in a manufacturing environment would need additional controls to prevent product and process deficiencies. Once we do the risk assessment, then we score the risks according to 3 dimensions, and we develop a prioritized list of these failure modes that need corrective action or need improvement. We're evaluating a design, we're evaluating a process assembly line or something, and then looking towards where are my areas of highest risk, and how do I now modify my design or modify my manufacturing process in order to mitigate that failure mode and reduce its severity or reduce the chance of it happening, et cetera. And finally, the FMEA is a form that documents the results of the risk assessment, of the analysis, and from the team. We do FMEA for our customers, right? So everything we do has to have a customer focus. And we recognize that there are several levels of customers. If a design deficiency manifests or a manufacturing defect is created, what would be the impact of that on an end user, someone driving an automobile? What would be the effect of that failure mode on my intermediate customer? It might be an assembly plant. It might be a manufacturing center, right? If some of you are contract manufacturers, you have two customers. You have the end user and you have the person who buys that product from you. Distribution centers could be a customer. Amazon, regulators, depending on the nature of your business, the FDA, USDA, whoever they are. If you have regulators in your industry, they're customers with needs and regs that have to be met. Of course, we all understand too that we have internal customers, the next operation, the next department. So always weighing failure in terms of how it will impact on my customer, internal customers and external customers alike. We use a team, and an FMEA is not meant to be just one of you sitting in a dark room creating an FMEA. It's about leveraging the power of teamwork. And the size and the composition of your team, of course, depends on your organization and the nature of the product or the process that you're analyzing. You have to have the right people in the room, 4 to 6 people, no more than that. Those team members, of course, require expertise, and your team has to have the time and the management support to do an FMEA. These take a long time. It's a significant investment of time and resources to pull off an FMEA properly. But you have to think of it as an investment and think of it as insurance against some future cost of failure, warranty, etc. We always recommend that FMEA have a comprehensive training program. Despite how easy I'm going to make it look for you today, it's not intuitive. And you don't just sort of self-teach yourself on FMEA. So you want a training program that includes management overview. Right? We have to let your senior leadership know how important this is so that they're willing to allow you the time and the bandwidth that you're going to require to complete one of these analyses. Facilitator training, right? You have a team in the room, and the team may or may not have FMEA expertise, but if one of you are the facilitator running the meeting, you need that high level of knowledge. So facilitator training, practitioner level training, maybe even supplier training, right? Depending on the nature of your business. And you may need to bring in suppliers and other stakeholders to also participate in your failure modes and in your risk assessments. You've got to do it early. I can't emphasize that enough. If you do your design too late, you do your FMEA too late, you say, oh, I wish we could change the tooling. I wish we could change this design. If it's too late, you recognize there's a deficiency, but it's too late to fix it. You've got to do it early. At the design phase, they tell us to do it at design freeze. Even that's a little bit too late. I call it design slushy, right? In your program timing, you've got to allow enough time for the FMEA analysis and the results of that to then generate, if necessary, more iteration in your design. It adds time. So do it early enough, do it when your design is slushy, so that if you have to go back and make design changes, it doesn't negatively impact on your program timing. Manufacturing process. You know how you're going to make the product. Do the FMEA at that point before you buy tooling, before you buy automation, because again, it's hugely frustrating when you have hard tooling, you have automation, and you say to yourself, oh, I wish we'd have built these features into the tools. Too late, too expensive. Do it early. The two forms are the same but different. If you look at the format of an FMEA, the format with its columns looks the same. It's virtually the same tool that you will use for a product design FMEA, product design risk, and a manufacturing process FMEA. But don't be fooled. They're very different. The approach, the thinking are entirely different. And if you're going to have FMEA training, don't get a class that teaches you both. It's one or it's the other. your audiences are different, right? Some of you on the call who are design engineers, you'll want to design FMEA. You won't need process FMEA and vice versa. So don't get a course that kind of mushes them together. Full disclosure, I teach FMEA for ASQ, and they have a class that puts them both together. I literally won't teach it that way. They pick one. My handlers there aren't that happy with me, but anyway, don't tell. So we're talking about failures of a design feature to meet design intent, including life cycle. We want to do FMEAs at a design level to reduce the cost of warranty. And in the automotive industry, that's been a huge driver for us. And FMEA tools have been credited with saving billions with a B dollars a year across the whole industry, because we're thinking ahead, we're thinking about what can go wrong, and we're reducing warranty in automobiles. We think also about manufacturing process and failures of some step in the manufacturing process that could result in a product defect, right? So when you think about it, it's the same tool, but very different in its application. So you want one or you want the other. Functions. If you've done FMEA, you may know what I mean by this. If you haven't, don't worry about it. But I have to be on the record every time I talk about this. You're assessing sufficiency for function. In a design FMEA, for example, it's the function. It's not a reliability exercise. It's not, what would happen if this capacitor burned out? It's not a component level fault tree. That's something else. It's about functions. What's the function of this design element to achieve, again, some greater function of the whole thing? And what's the function of my step in the manufacturing process? What does this step in my manufacturing process do? Let me take you through an example. Design. I've got this picture off the internet. Maybe it's a Google speaker or something. So I have a design feature. I want this to be bright white. It's got to look good. That's the function of this particular design feature. I've got this beautiful white plastic. It's got to look good. I have a requirement now associated with the function. What does look good mean? Well, I'm putting some life cycle to it now. My requirement is that this speaker continue to look nice and bright white and beautiful for 5 years. So there's a failure mode. How can my design fail to achieve design intent? How could my beautiful white speaker over time degrade in some way? Well, maybe the failure mode is that my plastic can turn yellow. A lot of white plastics tend to degrade under ultraviolet light. So there's a failure mode. My plastic discolors before the end of the life, and my customers are not happy. What's the cause of that failure mode? Well, the cause of that is I chose the wrong plastic. How do I prevent that failure mode? How can I prevent choosing wrong plastic? Well, my engineers have a lot of experience with color stable plastics, and they just know the right type of product, the right type of formulation to pick. It's color fast. Great. That's how I prevent picking the wrong material. If I pick the wrong material and I have that failure mode, I've chosen the wrong plastic, will I detect it? Right? Detection is all about if the failure mode happens, will I catch it or not? So yes, I have prototype testing, and part of my prototype testing protocols are accelerated weathering and exposure to very harsh ultraviolet light. So I'm going to build a prototype, bombard it with UV, and see if it stays nice and white. I've tested that, yes, I have a good color fast formulation, etc. Design. Deficiency of design. Manufacturing process. Maybe I'm just going to fasten two things together with a screw. Well, that's the function, right? I'm just, that's what I do. I have a requirement. I have to use a particular part number. I have to torque the screw to some value. There can be several failure modes, right? How can this process fail to meet its process intent? Maybe I use the wrong screw. What could cause me to use the wrong screw? Well, they brought me the wrong screw to my work cell. Do I have preventive controls in place? Why, yes, I do. I have dedicated kits of pre-counted screws, etc., and these kits are brought to my work area. Well, that's meant to prevent me now from having the wrong screws, because somebody else makes a kit, delivers to me only what I need. But if somehow I still use the wrong screw, will my inspection process detect it? And I say, yes, I have 100% camera inspection at the end of the line. So even though I have all these controls in place to prevent the wrong screw, I have some means of testing and checking at the end just in case. So you can see how robust this example seems. I have preventive controls to prevent using the wrong screw. And then on top of that, even if I do, I will catch it in some inspection process. Okay,
All
Raquel,
right.
another poll question. Let's have it.
Yeah. Okay, everyone. We'd like to know, which tool are you currently using for FMEA documentation and analysis? We got Excel spreadsheets, dedicated FMEA or QMS software. Some of you might have tools in place, but they're just not quite meeting your needs. Or maybe you're not currently performing FMEA, and so no tools for that process. Please submit your answers, and we will share them as soon as we have enough. Curious to know what everyone's doing out there. And I'm wondering if it's industry dependent, potentially.
I still use Excel.
All right. I think we've got our answers here. Let me share the results. So overwhelmingly, we've got 67% of everyone using Excel spreadsheets. Follow it up by those who just aren't performing FMEA currently. And then those who aren't using Excel, about 14% are using dedicated software for that. And 5% have some tools in place, but not quite meeting their needs. So very interesting results. Thank you, everyone, for sharing.
Well, and thank you for admitting that you still use Excel instead of more sophisticated tools. That's great. Thank you, Raquel. Jumping back in. So I want to talk about what I call the 3 dimensions of risk, right? So when you think about risk, you can think about it along these 3 dimensions. Severity, right? How bad would it be if it happened? And what would the effect of that, what would the impact of that be on my customers? Probability of occurrence, right? How likely is this failure mode to occur? And then finally, detection strategy. If it does happen, will I catch it? Or will this design defect or this product defect go straight out to my customers? So you can kind of see this intuitively makes sense, right? I want to think about risk in terms of how bad would it be. I also want to know how likely it is or how often it can happen. Because I could have something very severe, like a safety problem, that is not very likely to occur. Less than 1% likely to occur, but if it does happen, very, very severe, people die, I better put good control in place. Also, I might have something not very severe, but it's happening all the time, more of a nuisance. I might want to put appropriate controls in there in that situation as well. So on the FMEA form, and I'm going to walk you through it quickly here in a minute, you'll see that the FMEA form is kind of designed in these 3 zones. There's a zone for severity, and there's a zone for occurrence, and there's a zone for detection, and then there's a 4th zone for improvement actions, right? Based on risk, risk reduction actions you can take, etc. So I'm going to quickly just move through these definitions, and then we'll look at the format. A design FMEA, we're talking about the severity of weak design. And we use a scale of 1 to 10. 10, right? People die. It's a safety risk, or it's a regulatory compliance risk. And then, it's a sliding scale, 9, 8, 7. Do I have a loss of a primary function? Or do I have a degradation of some important function? due to product design. Then I kind of slide down into, okay, the product works just fine. It meets regulations, it's safe, but maybe now I have an aesthetics issue or some nuisance that, my machine has a little bit of a hum in it. Well, nobody cares. Maybe a few people care. So the severity is low. So we just use the sliding scale, right? 10 is injury or loss of life. 1 is no impact. And in various industries, in my industry, for example, there's a table, right? Tables are published that help give you some guidance there. What is the probability of occurrence of weak design? The probability of weak design. So now same idea, right? You just weigh this on a scale of 1 to 10, where 10 is always the worst. 10 is new design, state of the art, no experience, huge risk, right? Huge likelihood that somehow I don't get it quite right. And then, it's a sliding scale down from 10. Maybe it's a design based on a past product that I've made. I have some experience, sliding down. I'm familiar with the design. I've made a lot of these products. I have very strong testing protocols, all the way down to, hey, you know what? Almost identical design. We do this every day. We have a lot of field experience. It's a no-brainer, So sliding scale. FMEA, 10 is always bad. Sliding down towards 1, which is, trivial, no problem at all. Detection of weak design, usually prototype testing. So if I have a 10, right, very, very weak, no test procedures, if this design deficiency is in my product, go straight to market. I won't even see it. Sliding down the scale, unproven, unfamiliar test methods. I have reliable test methods. Maybe I do them late in the design cycle. So I catch something, but timing is compromised. So you do get some credit for doing testing earlier when you can. I have reliable test methods early enough to make design changes, no impact on marketing, no impact on production, right? So you can see how, as you slide down this list, the protocols are stronger. And again, it's a scale of 1 to 10. 10 is nothing, 1 is very effective tests. And it's also how well your testing replicates and represents reality in user cases, right? That's another one. Process FMEA, manufacturing process FMEA. So what's the severity of this manufacturing defect now? Is it a safety risk, regulatory compliance risk, loss or degradation of function due to a manufacturing defect? So you start to see, it looks like the table we just talked about. I may have high levels of scrap and rework in my factory, or lower levels of scrap and rework, or again, this manufacturing defect is more associated with aesthetics, or it's a nuisance. A scale of 1 to 10 again. 10 is injury, loss of life. 1 is no impact. Probability of occurrence of a manufacturing defect in my factory. 10, I have very high levels of occurrence. It's happening every day. And then it goes, and I have a low level of prevention. I may have moderate levels of failures with more effective prevention. And then as you get down towards 1 and 2 and 3 on the scale, parts per million level quality, error proofing, right? Can't make a defect. 10 happens every day, 1 is never. So again, severity of a product defect, a product design deficiency, or severity of a manufacturing defect, related, but not the same thing, right? Probability of a design deficiency or probability of a manufacturing defect. Related ideas, but not the same. Detection. If I make a bad product, will I be able to see it in some inspection or test, or will it go straight out the door? 10, I have no inspection or test, goes right out the door. Maybe visual inspections and things of that nature, not so effective. That's usually about an 8. Attributes, go, no-go types of inspections, variable inspections with gauges, automation, error proofing, can't make a bad part. So again, sliding scale. 10 is no inspection, 1 is error proofing, literally can't make it wrong. Design for manufacturability. This is a pet peeve of mine. If I'm in your design engineering office and I see that your FMEA doesn't consider manufacturability, I just lose my mind. If you're a design engineer, you're obligated to make sure your product, the product that you design, is easy to make as much as possible. So that's where it starts. The FMEA, the process FMEA team now also is going to look at your designs, and they're going to look at risks associated with manufacturing what you've designed. And we hope that they feed back to you ideas, right? Design improvements to reduce failures in the manufacturing plant. Things like design for assembly, asymmetry, etc., one-piece components. You can see it on the screen. So designers, consider a design in terms of how easy it is to make. If it's hard to make, that's design risk. Process engineers, think about how we can feed back to our designers ideas to make it easier to make, reduce our risk of manufacturing defects. Okay, let's take a few minutes and just walk through each of the tables, and this will kind of conclude the presentation, and then we'll take questions. So this is a long-awaited FMEA. This one's design, and you see what it looks like. It has 3 zones. The first zone deals with severity, the second zone deals with occurrence, the third zone deals with detection, and then we have recommended actions on the end. So of course, on the left, the first column is, what is the function? What is the function of this product? Or what is the function of maybe a sub-assembly within the product? Function. What is this design element intended to do? So back to my example, right? I have a design, a function of my design that it has to be aesthetically pleasing, it has to be bright, white, and beautiful. I have requirements now, right? The requirement might be for grain, for texture, for color, for life cycle. A lot of designers forget to put life cycle into the requirements. You need to do that. Is it going to stay bright white for a day or 10 years? So what's my requirement? We have to define the requirements very well, because I cannot have a failure mode unless there's a requirement. Makes sense, right? If I just say use plastic, I can use any old plastic and be compliant. So my requirements have to be very well defined and very well understood. Then, how do they fail? And there's often more than one failure mode for each requirement, certainly for each function. Once I know what my failure modes are, I assess the effect of that failure on my customers, the end user, my intermediate customer, maybe an internal customer, maybe a regulator. And then you'll see column 5, severity. Very skinny little column. That's where we plug in the number, 1 to 10. Again, 10 is injury, people die, 1 is trivial. So that's the first zone, right? That's the first dimension of risk. We talk about severity. Then we move into the second zone of the FMEA, probability of occurrence. Now we think in terms of cause. What could cause my design deficiency? Poor tolerancing, poor material selection, inexperience of my engineers, cause of a poor design choice. Then, what are my offsetting preventive controls, right? Am I going to prevent these causes of my failure? You think about them together, right? And then you take that net effect, right? This is something that can happen, but I have a way to prevent it. So I consider that net effect, and that becomes the probability of occurrence value that goes in the O column. Scale of 1 to 10, right? Then detection. And then the detection is one single column. It's just, do I have process controls or design controls that will detect this design deficiency? Again, usually prototype testing. Then we say, all right, here's my testing protocols. Here's what I've got to test for. How well will I test and see the design deficiency? How effective is my testing? Then detection column, scale of 1 to 10. The next column is called RPN. The RPN is the risk priority number. When you do an FMEA, it can become 50 pages long or more. Hundreds of lines. You can't work on everything, but you can work on a few things. And the final step in the risk assessment is a priority list. What do we need to work on first? You pick the top, 3 or 5 for improvement. The risk priority number is derived by multiplying severity number times occurrence number times detection number. So if my severity is 5, my occurrence is 5, my detection is 5, I multiply 5 times 5 times 5 is 125. That's my risk priority number. Once your 50-page FMEA is finished and you have all of your risk priority numbers, now you just look for the highest numbers, right? Remember, 10 is bad. I look for my highest number. I now can assign some recommended actions to improve the design, improve or drive down the likelihood of occurrence of bad design, or drive down the chance that my testing won't catch it, right? So I have recommended actions, responsibility, who's going to do it and when, and then you see at the very right-hand side of the page, SOD RPN. After we make the change, we ought to go back and recalculate severity, occurrence, detection. We hope that if we made a change, one or more of those numbers will reduce. You recalculate RPN, and the RPN number ought to be lower than it was. So now a higher risk priority number through some actions and improvement becomes a lower risk priority number. Process, FMEA, same idea, but we use you see the form looks exactly the same, but we're using this now as manufacturing process. So I have a process step, right? Operation 10, 20, 30, 40. What is the function of that process step? What does it do? Right? Insert a screw. What's the requirement? Part number, torque, has to be fully seated. And then for each of those requirements, it can have a failure mode. Wrong screw, too tight, too loose, not fully seated. Then I look at each of those failure modes again in terms of impact on customer. What would be the effect of this on a customer, end users, intermediate customers, internal customers? What's the effect of that on them? How bad would it be? Scale of 1 to 10. That goes in column 5. Then what could cause me to have that failure mode? What could cause me to have the wrong screw? Then I look at my current process controls for prevention, right? I bring only the kit of screws to the line. And now I consider these two, right? The likelihood of my failure mode plus the effectiveness of my offsetting preventive control. And that net probability of occurrence becomes the O value in column number 8. Pick it in 1 to 10. Current process controls detection, right? If it happens, will I see it or not? And what's the effectiveness of my detection, inspection, and test? What's the effectiveness of that? Scale of 1 to 10 goes in column number 10 in the detection column. And then again, risk priority number. You multiply S times O times D, gives you a risk priority number. Once the 50-page FMEA is finished, you pick up the highest numbers, come up with some recommended actions for improvement to drive the occurrence down or to make your inspections better and to reduce the occurrence, reduce the detection values. And then again, like we said, make the improvement, recalculate SOD, and then recalculate your new RPN. Okay, we made it.
Right. Thank you.
That is 4 days of FMEA training rolled into 1 hour, rolled into 45 minutes. So Please feel free to contact me and we'll take some questions. Raquel, I'm going to give it back to you.
Yeah, I did want to mention too, looking at last slide, I noticed that, that could have been built in Excel. And, obviously we offer a quality management software suite, including an FMEA application. So just want to throw that maybe some of the advantages of using a software like ours over Excel might be things like, integration with your other systems, version control, real-time reporting and dashboard, security issues. So there are, ways that we can help with FMEA that I'd be happy to, answer any questions for anybody if you want to contact Intellect post webinar.
Yeah, these database-based FMEAs like you're talking about can be really effective at preserving those relationships. If you've done FMEA, as soon as you change one thing, you're changing 30 things, and those databases can be hugely helpful. Yeah.
Yeah, thank you. So before we get into the Q&A, and I see a healthy number of questions in the Q&A section, here's the contact information to get in touch with Denis. There are links to his FMEA training courses. You can also use your cell phone camera, hold it up to the screen or in the slide deck that we provide later. Use the QR code to go directly to those course offerings. There's information on how to connect with Denis on LinkedIn. And I want to invite everyone to join our next webinar, which will be occurring next month on September 14th, which is a Thursday at 12 Central. It'll be on advanced auditing techniques. This is an area of auditing that is often, underlooked, but very important in increasing the efficiency of your audits. So please, everyone, join us for that. Go to intellect.com to get more information on that. Okay, let's head into our Q&A section. Let's get started. Denis, I'm just going to throw them at you. How can you use failure models to drive the FMEA early in the design slush phase? Usually prototypes will be made of different materials or using different manufacturing processes than the finished product, leading to false failure modes or worse, no failure modes detected.
Great question. Well, of course, first of all, your prototype has to be made, especially from a materials perspective, you got to use the right material because you're going to be testing a prototype for function with material A, and it seems to work just fine. Then you make it out of material B, and then all of a sudden it's failing all over the place. So when you do now, the manufacturing methodology might be different, right? You're not going to make like a circuit board. You don't make it on your wave soldering machine. You do it sort of by hand. But the function has to be right. The components have to be right to make sure that you're testing design, and then you can scale it into a more mass production mode. I think that's how I'd answer that question.
Okay, thank you. Next question, can FMEA be used to support a change in process or removal of a process?
Absolutely. You want to then do risk assessment on a change, right? In fact, ISO 9001 tells us to do that. So if I'm making a change, whatever it is, now I have to look at how does that impact my risk profile, right? If I'm, removing an automated inspection and I'm inserting a visual inspection, that the process will get a little bit worse, as an example. So yes, look at the nature of change and look at your FMEA and then reassess whether or not your severity probably wouldn't change, but your probability of occurrence of a failure may go up. That would be bad, or your ability to detect might go up or down, right? The number goes up. That would be bad. So 100% make FMEA review part of change management, 100%.
Okay, great. This question has a couple of parts to it. Our organization in the life science industry moved from FMEA to hazard analysis last year to be compliant with ISO 14971. I find that most people still don't understand or comprehend the differences. One, do you know of any good resources explaining the difference? And two, do you have any good advice on how to calculate P2, probability of harm occurring, given hazard situation occurred?
Yeah, I've read this, the 14971 because of my interest in FMEA. My advice, I don't know of any. First of all, the answer is I don't know of any comparisons that have been done. I'm sure they're out there. You could Google that. But I would just read them side by side. That's what I did. And then it's easy enough to sort of see what those differences are. And in terms of the approach on, med device safety.
And then do you have any good advice on how to calculate P2, which is probability of harm occurring given hazard situation that occurred.
Yeah, well, the thinking is the same. When you do the severity, whether it's in the hazards analysis or whether it's in an FMEA, it relies on you having a high level of knowledge of how your failure will impact patient safety or impact customer, satisfaction. So whether you're doing the safety hazards or you're doing FMEA, the answer to that is a function of how well you understand the relationship between kind of what you've designed and what your activities are and the effect on the customer. And once you understand that very well, then the analysis, the calculation should be fairly straightforward.
Okay, thank you. Next question, is detection ranking qualitative rather than quantitative based on your inspection methods? It can be hard to know what you're not detecting.
Well, it depends on your industry. In the automotive industry, we have published tables that are fairly prescriptive. And for example, they're not very open to interpretation. If you're doing visual inspection, it's 8, maybe 7. So it's qualitative in a certain sense because it relies on your FMEA team deciding, okay, how am I detecting a failure? And then I look at my scale of 1 to 10, and different teams, right, may decide, oh, well, this particular type of inspection or mitigation, I'm going to call it 5. Another team might call it 4. So yes, that's a downside risk, if you will, with FMEA, is that different teams can interpret and assign the SOD numbers slightly differently. There's ways to kind of normalize and standardize that, but it is a risk. Even if you don't have published ranking tables in your industry, you should create your own, because at the very least, you'd like to bring a level of repeatability between your own design teams or your own process engineering teams.
Okay, thank you. Next question. With probability of occurrence, where would you rate setup parts? We have a fabrication department and we always have one setup part that sometimes is bad. But once we're past that, the parts are always good as proven by our documentation.
So what's the risk that one bad setup part goes in the bin? Well, I guess you don't know, but you would evaluate the effectiveness of setup controls as preventive controls. Right? So there's a chance that I don't know, make a part with a hole in the wrong place. I prevent that through good, thorough first article inspection, first off, right, setup. And then once it's set up, unless I break a tool, it's gonna keep making good parts for me. So I think that's the basis for the question. We also have to recognize, I'll just interpret it the other way. We know there's a risk when you've got set up parts and they're bad, that you've got to scrap those right away. Don't leave them hanging around, because somebody's going to stick them in the bin and a part's going to get to your customer and they're going to say, what's this all about? And you're going to say, oh yeah, sorry, that was a setup part. So maybe that was kind of 2 answers, but setup controls usually go in the prevention column, and then the physical inspection of the first part would go in the detection column. You would take a line all the way across.
Okay.
It's challenging with some of these because there ought to be longer answers, but I hope this is okay, at least for today.
Yes, thank you. Well, they can always contact you, for your training courses or additional questions as well. Yes.
Great. Any more questions?
We do.
They're trying to stump the chump. I don't know.
Is the RPN value now superseded with the AP action priority number?
Yes. And for the person that is asking that question, I do have the new AIAG VDA FMEA upgrade classes ready to go. In the automotive industry, they've published a new guidebook. And yes, there were various drawbacks to RPN, fine. And yes, in this new version of the automotive FMEA standards, they've done away with this numerical multiplication business, and they've gone to an action priority. The concept is the same, except instead of it being a numerical value, it's 3 broad buckets of high risk, moderate risk, and low risk. And if something is high risk, then you ought to have improvement actions. So instead of having this scale between 1 and 1,000, this variable scale of risk, it's just 3 buckets of high, medium, and low. So yes, in that new model, AP does replace the RPN.
We've got a couple questions that are along the same lines. How do you document a revision history? And then similarly, how do you control revision history in the Excel type example that you showed?
Yeah, there's a couple of ways to do it, and there's no real guidance out there. I'll just talk about how I do it. Of course, you're supposed to put the revisions up in the header on the right side, in the upper right corner, and that's fine. But what's happening is if you make revisions, maybe you've had a customer complaint, you got to add a failure mode. What you do there is you add the failure mode, maybe you make it yellow, or maybe you make it gray. Maybe you can refer to a customer complaint number or something, because FMEA really should be used as a lessons learned database. You know, a lot of companies get all bent out of shape because, oh, we want to have a lessons learned database. Well, you know what? You got it if you have FMEA. So you can, if you're adding a failure mode, you can make some reference to a date or a customer complaint or something else to kind of show that evolution of your risk profile and your risk assessment. The other thing you can do is in the columns where you have recommended actions, you might have a recommended action. A year later, you might have another recommended action, and then there would be associated RPN recalculations associated with the first change and the second change. There's 2 ways to do it. You can take the recommended actions, and when you supersede them, you can throw them off to the left, put them in as current controls. If you have a lot of revisions, it can be hard to keep track of that. The other thing that I've had clients do, if it's Excel, you can actually just easily enough add columns. So every iteration, right? If you're adding new recommended actions, etc., and your evolution is not new failure modes, it's evolution of reducing occurrence and detection, you can add columns and you can literally show every revision to the FMEA it's in a stepwise fashion by showing the first one, then a few columns that show the second one and the third one. Now, don't print it that way because it'll be a big mess. But from a database perspective, that's another way to see the changes you've made inside. So I hope that answers the question for that one.
And I would assume this is where a tool like software would help with version control
It sure
and
can.
controlling things
Yeah,
like that.
great point.
Yeah. Okay. What is a reasonable RPN target?
I could have planted that question. There isn't one. You're meant to take action on the highest risks, because you know what we're going to do. We're going to set a target like 100. And then, oh, guess what? All my RPNs now come in at 99.5 because we don't want to cheat. You don't do that. You take action on the highest priorities, maybe the top 3, maybe the top 5. Now, fine. Some people want to have an honest way to use a threshold to guide their teams. It's hard to say. It depends a little bit on your commodity, I guess, if you're in the automotive industry, but it depends on what is high risk for you. If you live in the world of safety devices, right, you're going to have a lot of 10s in your severity column. You just will. If you live in the world of, I don't know, you're making a ballpoint pen, you're not going to have a lot of safety aspects to a ballpoint pen. So it's hard for me to say, pick a number like 100 or 200. It's a function of what your typical RPNs might look like. Because if you have a lot of safety, 125 might be a reasonable level, depending on other, if you happen to have less severe other things, that might be too high. 80 might be a reasonable threshold. So my first thing is don't have a threshold, just work on those top 3 or 5, whatever they are. You're going to have a threshold. It's kind of a function of what would be typical SOD and RPN values that you'd run into And then you draw a line where you think it makes sense.
Thank you. And that kind of answers another question about, where's the score or rate where you need to take action. So I think you can kind of answer that one
Yep.
as well. Yep, definitely. Okay, let's see. Next question. How would you assign cost to the potential defect?
Aha. How much time have we got?
Not much. We got a few minutes.
Because no, you want to do that. In my cost of quality lectures, I talk about this, right? You can actually put a value on your FMEA and on your control plan, but it's got to be the cost of non-conformance. It's got to be the cost of non-conformance at the customer. And if the non-conformance results in some safety risk, in somebody getting killed, well, that cost of your defects and the cost of non-conformance is very, very high. So now you're going to invest in whatever it takes to make sure you prevent those defects, right? At a design level, at a process, manufacturing process level. So that's what it is. You have to understand and weigh this investment you're making in FMEA and in process controls against that potential cost of failure. And again, if I make ballpoint pens and somebody doesn't like my pen, they throw it away and they grumble a little bit. But if I'm, making pharmaceuticals and somebody takes a tainted pill and they die, not the same thing at all. So it's that cost of non-conformance, cost of external failure, liability, lawsuits, warranty, recall. That's how you have to do it.
Got it. Thank you. So we'll go a few more minutes over. We have a lot of questions. I don't know if we'll get to them
I'd
all.
love to hang around if somebody wants to do
So
that.
we'll take a few more minutes. Again, you can reach out to Dennis, on his, all the links that are on this presentation. We'll provide them, of course, after the webinar as well, but we will take a few more. Let's see here. When should PFMEAs be conducted? Once the initial manufacturing process plan is developed but not implemented? Is this at alpha phase, beta phase, or just prior to pilot?
Do it before you start designing and building tooling and automation. I said that in the presentation. You got to do it as early as you can. Once you know how you're going to make it and sort of, the operational steps, then do FMEA right as early as you can. The FMEA will also evolve, right? So you can almost do it at a concept level. And then as you put more meat on the bones, you continue to refine and evolve the risk assessments. You got to do it early, because if you do it too late, you say, oh, I wish we would have thought of that ahead of time. We would have bought different equipment. It's too late.
Okay. Let's see here. Is FMEA an internal document? Does it need to be shared with customers continuously when it's updated?
Good. You usually don't share them because it can be full of proprietary stuff and secrets. Now, having said that, in the automotive industry, we're required to give them to the customer as part of the package. So I guess if you're in an industry where you have to give them to your customer, then you do that. But I think if I have a choice, I'd keep them to myself, especially for designs, right? Because you get into design risk and other things that you may not want to share with the world.
Okay. These questions are somewhat related. I'll read them both before you answer. Do you typically generate an FMEA per product or project, and then also, do you think FMEA is suitable for a company that makes thousands of different products? If so, is this process time consuming and costly? How should it be effectively implemented?
Yeah, great question. We have family FMEAs, right? So families of products maybe can share a design FMEA, manufacturing processes. So let's say I run a paint shop, right? And I'm going to put lots of different parts through my paint booth, but the risks associated with painting a part are all the same, right? I got to clean it. I got to pre-treat it. I got to get the coverage right. I got to get the cure right. So I can have one FMEA for a manufacturing process like painting, and I can have literally thousands of different part numbers that run through that. So you would be encouraged to create a family FMEA or a baseline FMEA. But then what you do is when you have a new product or a new process or something new come into your business, then you assess what risks may exist in the new part that will manifest themselves in the basic process. For example, back to the paint example, I know that there's risks if I'm going to paint a part with getting coverage on the part. If I run flat parts, they're easy to paint. The risk of me not getting good coverage is low. If I run a part that has lots of bends and angles in it, there's a challenge. I'm not going to get paint everywhere. So it's one risk, not fully covering the part. But the occurrence changes based on the geometry of my part. So you start with the basic baseline family FMEA, you take the new part, and now you evaluate these garden variety normal expected failure modes against the new part. The new part will have different material, it may have different geometry, and that's where now you say, okay, will this be higher risk or lower risk than my average parts, if that makes sense.
Yep.
But yeah, try to bundle them if you can.
All right, I think that's all we have time for. Thank everyone for coming. Thank you so much, Denis, for sharing all of your knowledge. If you have a question again, please reach out to Denis. You can reach out to me or anyone at Intellect as well if you'd like some more information on our tools. Thank you, everyone. Have a great day and good luck with your FMEA process.
Thanks, everybody. My email is on the screen. I hope to hear from you. Let me know if you have any other questions. I'm here all day. Thank you, Raquel and Ann.
Thank you.
For the opportunity, and everyone have a great afternoon.
All right. Thanks, everyone.